So hello everyone. I'm not sure if it's good evening or good afternoon, whatever you are. You're most welcome for this webinar once again with CBT and now fully in English. So I do hope we have lots of colleagues from all over the world. Before I continue, I want to make sure everybody's hearing me. So if you cannot listen, please just let us know in our chat. I guess this time is okay. Okay, so we have our channel, CBT, the Brazilian Tunneling Committee. If you haven't done so, please follow us and give like in the video. We have a bunch of videos, most of them are in Portuguese, but we are having several ones in English, and the idea is to continue that. So yes, okay, thank you, Jairo. We are heard. Great, thank you, Valentin. Great, so CBT is completing 30 years this year of existence, and this series of webinar is a way to celebrate the 30 years. And tonight we are going to have again our colleagues from Meidel Consultants. Unfortunately, Dr. Ulrich Meidel could not attend tonight, do a field trip, but we have the engineer Mark Comulada. So Mark Comulada has been working at MTC for over 18 years, and he graduated in civil engineer at the Polytechnic University of Catalonia in Barcelona. Mark is company procurator and head for international projects and has participated in all tunneling project stages, from initial feasibility studies, bid preparation to detailed design and construction of large TBM tunneling projects. He possesses a wide hands-on experience in tunneling, having assisted several job sites worldwide, covering all existing TBM technologies in a wide variety of ground conditions. About MTC, the invited company tonight, MTC counts among the world's leading experts in TBM tunneling, providing design and consultancy services to owners and contractors. They have a very close and familiar relationship with Brazil, where they have been providing service to the largest Brazilian contractors since 2002. As some examples, São Paulo Metro, lines 4, 5, 6, as well as Rio de Janeiro, line 4. Before I give the floor to Mark, I just want to remind you that please send us questions and participation in the chat. I will be checking here constantly your comments. So let's be active and then also give space for discussion. So Mark, please, the floor is all yours.
Okay. Muito obrigado, Daniela. Boa tarde, pessoal. So thank you very much for again hosting this webinar and for inviting us once again. We're very happy to participate in these activities and now especially in Brazil where we see, fortunately, the projects are again all starting line 6, line 2, and there's a few things going on in Brazil now. So it's also an exciting place to be, even if it's only online for the moment. So I would like to start the presentation. This time we're going to talk about risk management in shield tunneling from the bid preparation until the construction. So first of all, well, this is the structure of the presentation. We're going to go through a very brief introduction just to show the setting, how we're going to approach this topic, because we can approach it in many ways, but we're going to approach it in more a little bit more in a practical way, I think. And then we'll go through the aspects like tender documents and the baseline conditions, then the bid preparation stage where we have to frame risks, then the risk management during the actual construction of the tunnel, and finally some remarks. So to start with, we have, as an introduction, presently we have actually a boosting tunneling market worldwide. and there's a lot of projects going on. Then there's a lot of projects with very large tunnels. Tunnels are getting larger for motorways and also even for subways. We have situations with very large diameters, and now tunnels are planned in basically in all types, any type of ground. I remember when I started working, we were actually sometimes adjusting the alignment during the construction stage as we gained information on the geology to avoid certain difficult geologies sometimes if it was possible. But now this does not happen. Now they just draw the alignment wherever it is, and you're going to hit any type of ground conditions, and sometimes they're really, really tough. And then we have, obviously, tunneling is a risky job in terms of safety. There's no doubt. There's a lot of it to take care of, to make a safe environment for the people working there and for any third party around the tunnel. But it also involves, and this is one of also the focuses of this presentation, losses. Yeah, we have so many cases of projects where there's losses in the amounts of tens of millions of dollars, and this is a problem. There's no doubt, but this comes from an extremely competitive environment. Let's say that the competition is very, very tough among all the bidders, among all the companies, and with very tight financial budgets. And then we have the situation, we're going to deal with this today also, with sometimes I would say an equal or unfair risk distribution between owners and contractors. It's really sometimes very tough contractual conditions and liability conditions. And we have many times tender strategies or approaches that are basically or mainly based on pricing. So I think this is the framework, or let's say a snapshot of the present situation nowadays, how it is internally. And you can see on the right-hand side, I've put some photos. One is like a snapshot from a video of the Alaskan Way Alaskan Way viaduct replacement project in Seattle with the largest EPB ever. And you can see it was constructed really very, very close to several foundations of the viaduct, etc., in difficult ground conditions. And at the bottom, we have a nice photo of a difficult blocky rock conditions, which is the geology, of course, and the technical conditions we encounter are one of the main aspects of risk. So going to the tender documents, basically, firstly, there's this code of practice I would like to show from the International Tunneling Insurance Group, where the insurers basically made a very nice exposition of the situation and how to best reduce risk, like what's the main structure that one should follow when doing risk management. It's a completely voluntary code of practice. It's not a norm or anything like that. And it applies to project development, design, contract, procurement for construction. So basically to everything except for then the actual operation of the tunnel. And it defines the basic structure of a risk management process that starts with the hazard identification and their consequential risks in the different project stages. We obviously have many project stages to consider. Then we have the evaluation of hazards and their probability of occurrence. And then we have one of the key issues, which is the definition of the strategies that are appropriate for preventive actions and for contingent actions. And then they also, let's say, recommend or explain the use of risk registers. And that is something that everybody more or less is doing, prepare the different risk registers for the expected risks. And the risk registers actually are documents that clearly indicate which part is responsible for the control and management of the different risks. Yes? So it defines the risk allocation, which is actually a very important aspect, who's responsible for what. And another very important aspect from this document is that the risk registers are live documents. And this we will see also in the presentation. As we advance the soil investigation, as we advance with the design, as we advance with the construction, we always get new information on the project, and we need to always be updating those risk registers. The different risk levels have to be updated continuously. And this is a focus very much on technical risks, but we don't have to forget also we have contractual risk, or let's say contractors have contractual risks. And I'm going to, the approach to this presentation is, as I mentioned, it's from bid preparation to construction. So you can imagine it is a bit focused from the point of view, let's say, from the position of contractors. So to start with, we have also the baseline conditions. The baseline conditions are the conditions given generally in the tender documents, and one of the main aspects are the geotechnical baseline conditions. And here we have, for instance, from the American Society of Civil Engineers, the GBR, the Geotechnical Baseline Report guidelines, which define the risk and liability framework of the owner versus a contractor. And they're actually very well formulated guidelines, which unfortunately are not always followed, or I would say very rarely followed. And the idea of a GBR is to set clear, realistic baselines for the conditions anticipated to be encountered, and provide all the bidders a single contractual interpretation of what is expected. Okay, so start from a fair, let's say, starting point for all the bidders. And then obviously the other main purpose of the GBR is to understand all the ground and groundwater conditions at the site, and also to be able to estimate the financial risks associated to all these conditions, and very important, to clearly allocate the risks between owner and contractor. This is very important. I mean, the geotechnical baseline conditions, and this rarely happens, must clearly define up to what point is the contractor responsible for the job, for the design and for the construction, and from what point we can consider it's something that the contractor did not have to expect, and it's not in his liability. So this rarely happens. You have several regions of the world with different strategies, but this we have many times where the risk is posed basically on the contractor. Many situations. But in the US, I must say they do follow, we have the impression, at least from projects we know, they do follow these guidelines quite well as far as possible, because the geotechnical investigation is never as good enough to make a completely, let's say, fair and perfect baseline, but still it works quite well there. And then we also have the FIDIC Emerald Book, Conditions of Contract 2019, where I'm pointing out this document because it is also pointing out how important the risk allocation is. Yeah, and it's the FIDIC conditions are clearly stating that you have to foresee potential remeasurements in time and cost. Yeah, so it's really, again, trying to be more fair, I think, to the contractors, and providing the tools to measure, actually, if I think I've encountered different conditions than expected from the interpretation, from the tender information, you've got to give the tools to remeasure those differences and to provide compensations if possible. So this is, we do have these guidelines and these conditions, which are all actually very, very fair and very nice, but we unfortunately, it's not always as nice as these guidelines try or attempt. Correct. So then if we go to the bid preparation stage, that's when the contractors receive all the documents and they have to prepare a price at the time scheduled for the project. So it's vital to frame all the risks involved in that project. And And here on the right-hand side, I've got this table. You can see we'll go through several topics in this bid preparation aspect, which is one is the ground conditions. Then we have the design, and then we have some case studies or examples, and also finally the risk and opportunity evaluation. So the ground conditions, yeah, they are the key starting point for everything, basically, for designing the works, for assessing and pricing the risk of your bid. And they are one of the points or one of the aspects that have a major effect on time and cost, in tunneling, obviously, and insufficient ground investigations or poor interpretation of those investigations is one of the most frequent causes of collapses of this case. This is information from the Advanced International Technical Loss Adjusters. So obviously, this is the first starting point, making a good soil investigation program and a good interpretation of that information. But in reality, we have investigations which are often limited. I mean, we know in tunneling, it's always going to be limited. There's always a maximum number of boreholes we can realistically do. So, but in the tender stage, it's sometimes pretty critical. Yeah, there is sometimes quite a lack of information at the tender stage. And besides that, we have short tender periods, and also the reality shows that it's difficult to assess this risk accurately. And then obviously conditions different to those expected can have a major effect on time and cost of the project. And that's the ability and the experience of the different contractors when preparing their bids in actually being able of measuring, of framing these risks. And then there's another point, important point, that generally enforcing ground condition risk is not insurable. It can't be, it's not an accident that's covered by the insurances. So just to point out a little bit, I mean, I think most of you watching the webinar know this, but I think it's important just to make the difference. What are very overall view of the ground we can encounter in tunneling. Obviously, on one hand, we have the soils. The soils are generally unstable ground conditions where an actual support is required. Otherwise, we can have, let's say, a collapse or an instability. And not only that, it's not only about stability, but it's also about settlements. Especially in urban areas, we induce settlements at the surface or even underground if we're crossing underground structures that have to be controlled. And then there's other aspects that affect directly the costs, time, and potential losses of contractors is the tool wear in abrasive soils. A soil, it doesn't mean it's easier or it's less abrasive than a rock. There's soils that are much more abrasive than rocks, for instance, to cut the bottom, excavate them. And then we have another big issue. Sometimes it's the clogging in sticky soils, which is some hindering the projects and producing additional costs. And let's say the upside of all this is generally in soft ground, contractors can attain high advance rates. They can expect high performances, which is always, let's say, good. It's one of the positive aspects. And of course, you see images, the soils can be unstable and tools they wear. So all this has to be considered in the bid preparation, obviously. And then in rock conditions, here at the bottom left, you have a very nice rock with a flat surface. You can see the paths of the disc cutters. So we have a situation where still it's hard rock, but it can be excavated relatively easy. But still, generally, rock implies, or in many cases, rock implies high foot consumption due to the wear and the energy we need to actually cut the rock. Yeah, the rock is cut with the disc cutters, forming the chips you can see here on the top right. This is the main purpose of the disc cutters installed on the cutter head to generate these rock chips, which we can easily then transport towards outside the tunnel. However, it's not always like this. Many times we have blocky rock, or the rock is fractured, and we have it generates, when we cut in the rock, the fractures can generate loosened blocks. You can see a very big block here loosened in front of the cutter head. Obviously, you can imagine that when the cutter head is turning, trying to cut this rock, it will suffer from severe damages. Trying to cut this block it will be moving, and it won't be a nice rock like the one we see on the left to cut at. And on the right-hand side, well, there's another video with pretty bad blocky and rock conditions. So you see the tools wear here. Also, we have a disc cutter, an image of disc cutter wearing. So we have this wear and tear of the tools in rock very much. And then we have the mixed ground. Yeah, and mixed ground, I think many of you watching this video from Brazil, you have experience with these grounds. We've lived them, we've had them, we've got experience with them in Sao Paulo, in Rio, and it's actually pretty tough. Yeah, and what does mixed ground consist of? This is a long section in Singapore. We have several areas in the world with a lot of mixed phase conditions, in especially tropical weathering in tropical areas. And the yellow layer here is a residual soil resulting from the weathering of the rock, which is located at the bottom in color orange. So in this case, we have the tunnel, the two red lines crossing exactly the transition between the sound rock, the good rock, and the soil. And this mixed ground condition, now I will show you, poses a lot of difficulties when excavated with a shield, in shield tunneling. Yeah, here you can see the typical weathering grade of the rock at the bottom, grade 1 and 2, basically, let's say, good sound rock, grade 3 and 4, start to be more fractured. And as we go further up, closer to the surface, grades 5 and 6 are already more or less like soils. So it looks, we have a look at this in photos from reality, let's say. We start from the bottom left. Here you can see sound granite at the very bottom. That's a granite weathering grade 1, 2. As I mentioned before, a flat surface, no blocks, and you can cut your rock chips very, very easily and nicely on this face. But still, we can have a high tool wear rate. It's a hard rock, and this generates a lot of wear on the tools. Then we have conditions where the rock is starting to get more fractured, like rock grades 3 and 4, and we start having more blocks on the tunnel face, loosening of blocks. And here, in addition to the high tool wear rate, we also have impact loads acting on the cutters and generating more damage on the cutters. And then if we continue further up, closer to the surface, we start getting a higher weathering grade. Part of the rock has already weathered into sort of soil, but we still have, let's say, sound rock boulders, sound boulders within that matrix. And here we start getting these boulders trapped into the openings of the cutter head or trapped between the tools, and we start to have blockages, and they start to drop in addition to the other ones we already had. And finally, when we get to the upper layers where we have more soil, then we start having ground instability. The soil isn't stable, so we have to start stabilizing it, pressurizing the shields, and with some, generally with water. So in this situation, you can imagine we have a whole combination of risks that are occurring at the same time and on the tunnel face. And then there's obviously a variety of additional risk conditions related to the ground or indirectly to the ground, like karstic cavities, for instance. Then environmental risks, like contaminated soils. We have the situation of the two super large EPBs in the Westgate project in Melbourne, Australia, where the shields are built there, but they've been stopped now already for several months since they found out the soil contains PFAs, which have to be obviously treated very specially and special disposal sites. And this is delaying the whole project. And this is a risk that just appeared. Yeah. Then we have also risks related to noise due to the equipment that you generate noise in urban areas, which is not invisible, and disposal issues, as I mentioned before, also. And then we have sometimes restrictions to the construction procedures. Sometimes we have space restrictions, and we have to build the tunnel or advance the shield without installing the backup, for example. And you can't have a continuous drive. You have to excavate, let's say, 10, 15 centimeters, then stop, extract the material by cars, whatever, and then you can start again. So there's sometimes these restrictions to the construction procedures, which imply additional risks to the tunneling process. And also we have many projects more and more with extremely high operational pressures when they're very deep with connection to groundwater tables, 150, 160 meters under the groundwater table. So how do we deal? We have all these wide range of geotechnical conditions, wide range of technical and geomechanical parameters from the soil investigations. We normally have a minimum value, a maximum value, an average value, quite a wide range. And many times the information is not as complete as it should be to have a full view of all the risks or to quantify all the risks properly. The information is rarely available completely. So we have this problem because these are all key input values, these ground conditioned parameters, these ground or geotechnical parameters. They are key input values for the construction method and equipment selection, number one, and also to estimate the performance of your tunneling works and the consumables. So all the things that are generating cost and time, actually you base mainly on the geotechnical conditions, and these are not always as complete as they should be. Yeah? So there's a lot of interpretation going on there. So obviously there's a high degree of uncertainty. And that's why an approach, at least what we follow, is follow several scenarios. A base case scenario based more on average parameter, a best case scenario based on the good technical parameters, and a worst case scenario based on the poorest geotechnical parameters, more or less. And then one has to assess, and this is where the key comes with experience, the likelihood of occurrence of the different risks in the best and worst case scenario, and also the consequence. Yeah, this is a typical matrix you can see here at the bottom with the likelihood and consequence evaluation, and from there you determine the risk level. And once you have the risk level, then you can decide, okay, what is weighing more? Is it the base case scenario? Is it representative? Or maybe if I'm closer to my risk evaluation is telling me I'm closer to the high and extreme levels, then I should put my estimations more on the worst case scenario. Or on the other hand, if the risks are low, then I can be a bit more optimistic and base all the estimations on the best case scenario. So this is how basically contractors have to deal with these risks. And this is very summarized. It's all very complex. There's a lot of studies to do this during the bidding stage in a very short time. But this is more or less the procedure. And then, of course, based on all this, you have to decide the main tunneling method, which most of you here know about. And we are focusing today on TBMs. Sometimes the tender documents are already prescribing the construction method or the tunneling method, but sometimes the contractors have to decide which is the best method. And that is all based always on these geotechnical investigations. And obviously then focusing on TBM technologies, as I mentioned, that's the title of the webinar. So as you all know, we have the EPB shields and the slurry shields, where EPBs, I'm not going to explain what an EPB is, but the concept of EPB works with high densities in the excavation chamber with dense muck, whereas the slurry shield works with more liquid muck, what we call more a low density. This is a crucial difference in selecting the two methodologies. And in between nowadays, we have what we call the hybrid shields, like the variable density shields of Herrenknecht shown here in this picture, where you can adjust more or less the density in the excavation chamber. So it's covering the scenarios of the EPBs and of the slurry shields. Well, these are things that we explained, I think, in the previous webinar. And then, so based on the ground conditions, we can do a selection of the TBM. That's, as I mentioned, something we dealt with in the previous webinar with Ulrich. But there's other factors which are very important, and for the contractors when deciding what technology to select. And one can be as easy as the availability of refurbished TBMs, maybe, because those are you don't have to build them from scrap, so they're available in a shorter time. That shortens your construction schedule, but maybe they're not the 100% perfect TBM for that ground, but they give you another advantage. Then there's also other aspects to be considered when selecting the TBM technology, like restrictions on the muck disposal or the surface available on site for all the site installations, and obviously also the experience of the bidding team. And we have projects, remarkable projects, where the technology has been selected sometimes more based on these factors than on the strictly geotechnical factors. So all these factors, it's not only the geology in this case here, there's all these factors that are then, let's say, molding or varying the risk level of the project. So this is a little bit like an example. Yeah, you have, this is in Kuala Lumpur, and where we have the blue is the limestone, and you can see the cavities, and some cavities are estimated or have been determined by the boreholes to be infilled with sand, and others are voids, are empty. So here, in deciding which is the TBM technology, one carries out the assessment of different parameters, like the capacity of stabilizing the phase in these conditions, the tool wear, the level of tool wear, blockages of the screw conveyor, in this case an EPB. On the left-hand side, this is the evaluation for an EPB, where we identify, let's say, the key critical processes of the EPB tunneling technology, like the phase stability control, tool wear, clogging, transfer of the muck for the belt conveyor, and mud disposal. So all these aspects can be evaluated in terms of risk. Then we can do the same comparison for a slurry shield technology, comparing different aspects also for different critical positions on the slurry shield technology. And in this case, you finally come out to the conclusion that, in this case of Kuala Lumpur, a situation between an EPB and a slurry shield would be optimum, and that's more or less where the variable densities were born in a situation like this. So here there's another case study I would like to present from, let's say, an improper risk evaluation of geotechnical conditions, in this case, in combination with the TBM, or even a design aspect from the TBM, which is the operation mode. This is an EPB shield that was also equipped, let's say, a multi-mode EPB that was also equipped with the possibility of installing a belt conveyor to the center in order to excavate in open mode. So in this case, the designers decided that this first stretch of the tunnel that was excavated in a soft rock, it could be excavated in open mode with a belt in the center. And you can see this project also had an inclination of 4% in the alignment. So the first 100 meters, they encountered this soft rock, which was, let's say, more or less easy to cut, but they had problems in steering the TBM, because when you're operating the shield in open mode, That means with no pressure at the front. Here you can see with all these arrows on the right-hand side, we have always, you know, the TBMs always tend to tilt forward because of the weight. The center of mass of the TBM is pretty much forward in the cutter head. So it's always necessary, that's what we show with the orange arrow here, it's necessary to push harder from the bottom and not so hard from the top in order to counteract this tilting of the TBM. In this case, we have also, so this is generating, let's say, a moment from the side of the thrust jacks, and from the front we have the moment contracting in the other direction of the TBM, trying to tilt, of the weight of the TBM, and we also have the contact of the cutter head. And in these situations, with a very soft rock, we were only getting contact in the very bottom of the cutter head. So actually, this was actually generating also a large moment against our reaction with the thrusts. So it was impossible to actually attain the 4%. So actually, a deviation of up to 6 meters occurred from the alignment. And well, it was decided obviously to change the operation mode to closed mode. So that means it's the same TBM, but it's a design criteria with not to operate in open mode, operate in closed mode, which allows you with a screw conveyor instead of a belt in the center, which allows you to pressurize the excavation chamber. And this gives us the effect of the counter pressure in the excavation chamber that helps us to balance, helps us to increase the thrust force of the thrust jacks. And this allows us, for this moment given by the difference between the bottom and the top of the thrust forces, to counteract all the other moments that are trying to tilt the machine forward. And this made it possible then with no problems to maintain the 4% grade. So what I'm trying to say is these aspects of design also. Yeah, it's a design aspect to decide that TBM is going to be operating with pressure in certain stretches or without pressure in other stretches. And this is also a risk that has to be measured, also these design aspects. And then there's also more an operational aspect that, in addition to this problem, when you're operating in open mode, like here at the top, it's generally not possible to inject foam on the cutter head. So it wasn't possible to condition this soft rock. So we had situations like this one you can see in the photos at the bottom left, with just impossible to condition, but impossible to extract it. It was just filling the chamber, and it was being extruded through the openings in the bulkhead. So these are risks that they just happen, you know, and these are also, I would say, avoidable if one has the whole perspective of technical conditions and the construction methodology. And then there's another aspect, as I mentioned, that it's all, we're focusing this from the view of the contractor, from the view of the TBMs, and you have the cutter head. Cutter head is one of the key components of shields, and it's in charge of cutting the ground and evacuating it as efficiently as possible from the face towards the excavation chamber and then towards outside the tunnel. So here, the design with the quantity of tools and the opening ratio and the distribution of the openings of the cutter head, that has to match the ground condition extremely well. And it's also a component. It's a component of the TBM that suffers most wear and tear. And obviously, it's also an aspect with larger diameters. I commented before, projects are getting larger in diameter worldwide. We have higher wear rates. We were talking about this also in the previous webinar. And so the design of the cutter head is crucial, and it has to be adjusted to the ground conditions. And then the operation. It's not only the operation of the cutter head, the balance of the adequate rotation speed and the contact force of the cutters against the tunnel face. That's also crucial to avoid the risks of damages and excessive wear on the tools and on the cutter head. So cutter head is a design and operational issue that has to be taken care of. And then continuing with the cutter heads, so that you realize how the ground conditions influence the design of the cutter head. Here I'm showing two extreme cases: a purely rock TBM cutter head, very closed cutter head with a lot of discs. You need a lot of disc cutters in order to be able to cut all those chips of the hard rock, cut that rock into those little chips that then fall by gravity and are picked up by the buckets that you can see here on the periphery and transferred behind the cutter head. Whilst in soils, we have a situation with a much lighter cutter head. It's not going to be as robust as the cutter head in rock. It doesn't have to handle such high forces. It's just got to allow the soil to flow towards the excavation chamber, and you need less tools to excavate it. Okay, but then, as I mentioned before, with mixed phase conditions or mixed ground, then we have a compromise design, because we have situations with rock, we have situations with blocks of rock mixed with soil, and we have situations with purely soil. So this situation is where we have to approach a compromise design. Yeah, and in this case, you have a cutter head that has to handle also very different forces. You can have rock at the bottom, and you can have soft soil at the top. So you have a very high balance of reaction forces against the cutter head, which has to be also considered in the structural calculation of the cutter head. And actually, there are projects where there's damages on the cutter heads due to these high different loads on the cutter heads. And in addition, obviously, there's other elements like the tools. You can see broken disc cutter, or like in the openings, the grizzly bars components that are bending in the excavation chamber, or sorry, bending on the cutter head due to the presence of blocks, for instance. So these design aspects of the cutter head. It's in many projects one big problem and one big risk that ends up generating a lot of losses in terms of money and also in terms of time. So all these aspects should be considered during the bidding stage when a contractor is preparing, estimating all their costs and all the risk level, and that's where they do their risk and opportunity evaluation. So you have to be able to foresee the ground-related risks, and this requires thoughtful and expert evaluation in order to do the right TBM selection and the right TBM design and specification. Then you must also be able of planning a contingency for foreseeable eventualities based on the risk assessment. These contingencies are crucial actually in the bid preparation. And then approaches like the one I mentioned before with best, base, and worst case scenarios in order to estimate advance rates, TBM performance, consumables of tools, of ground conditioning products, and also obviously to estimate the interventions. Yeah? And here in this evaluation, there's generally a high level of uncertainty. Yeah? We have very different scenarios between the best and the worst. And the contractual baseline conditions, we're talking about very technical aspects here, but then we have also the contractual baseline conditions. You need really the legal guys checking what is your situation contractually, where is your responsibility limited, is there a limitation to your responsibility or not, so you know where you can act in the contract. What tools is the contract giving you in case you encounter different conditions than the ones provided and the ones you have been interpreting in order to do your cost estimation. So in this sense, it's very important from the beginning, already from the bid preparation stage, to already have, I call it here, pre-cook the compensations or claims. Yeah, I mean, just you have to know which are your tools you have to be compensated if you have differing ground conditions. Yeah, and it's important to prepare them to know what they can be in advance, so you can document them timely and submit them timely. Yeah, that's very important. We have many situations where there's claims from contractors, and they just claim things that they say happen, but there's no documents providing evidence of that what happened, because more or less they realized too late of what was going on, or that things weren't going on properly, and they weren't documenting it timely. So this has to be prepared from the very beginning. I think if the contractors want to be ready to be compensated adequately for differing ground conditions. So now we go to the construction stage. So during construction, I'm focusing here on the TBM performance, because TBM performance is related to time and financial costs, basically, in the TBM tunneling projects. So one aspect is the net advance rate. How fast can I excavate in this ground? Can I excavate as fast as I planned in this rock or in the soil? Then there's the aspect of the interventions and tools, intervention spacings. This we already presented also in the previous webinar. You can plan your intervention areas, designing safe havens to do interventions, but you'll also have situations where you have to do compressed air works in difficult ground conditions, requiring all the equipment and all the time to do hyperbaric interventions. And then we obviously have the logistics behind the TBM, so that everything works, also have to work perfectly. So, and here I've done my own estimation on how much the ground conditions weigh in each of these three aspects, or more, let's say, human conditions, like from design and operation. So I think the net advance rate is normally more affected by design and operation than by the ground. Yeah. Then we have the interventions and the tools. Here, I think, is where the ground provides a high degree of uncertainty. We don't have so many good models to estimate tool wear, or then or the damages on the tools, etc. So, and this is something that where a lot of money and a lot of time is involved. So, and I think here there's a higher weight of the ground compared to design and operation. Yeah? And we have our limitations. It is one of the main limitations in TBM tunneling is the materials we use to cut the ground, etc. The tools they can cut and they can handle what they can handle nowadays. And obviously things are improving, but we have these limitations. And then the logistics. Logistics is basically more a planning aspect. It's more depending on design and operation. And so then construction. Yeah, this is the main key for risk minimization is the validation of the design during construction. This is actually one of the premises of the risk code of practice, and it's very important that the contracts make provisions for monitoring of the tunneling works, and also that trigger levels are defined at which contingency actions must be taken. This sounds very obvious, but there's many processes involved which need to be actually monitored. So here is where we always point out how much digitalization nowadays can help in minimizing the risks during construction, since an adequate interpretation and, let's say, a timely, as real time as possible interpretation of the ground conditions allows us to identify risks that we cannot know anyway. Here you can see an example. This is the profile of rock in Singapore, and you can encounter mixed phase conditions, and you can identify these mixed phase conditions from the TBM data, studying the eccentricity, analyzing the eccentricity of the thrust jacks of the cutter head, respect to the cutter head contact force. We can actually identify situations more like full face rock or more like mixed phase. So identifying these, since we're excavating in grounds which the transition from rock to soil is very variable, and in many situations it cannot be foreseen everywhere, we have to use these tools to identify these conditions and to adapt then the operation of the TBM to the encountered conditions. And this is an example here. You can analyze in the penetration index at the very top. The penetration index is a contact force of the disc cutters divided by the penetration. So the higher it gets, it's indicating the higher it's the more difficult it is to cut the rock or the material. And then we have the specific energy of the ground. We also taught that in the previous webinar, which is indicating the energy per cubic meter that I need, so the energy I need to excavate 1 cubic meter of ground. And here, this is an example of a nice example. Here you can see the ring numbers 143 to 148. So these are 5 rings where we were actually working with low penetration indexes, typical of soils, of a soil-like material. We had reasonably low specific energies. And here we can see from the pressure distribution in the excavation chamber, we're operating in closed mode, indicated by the picture here below. So as soon as the specific energy started to increase to values that we know are critical and that induce very high wear and damage on the tools, and at the same time, the penetration index is increasing, it's indicating, okay, the rock phase is getting better, penetration index is increasing, so it's getting more a rock type phase than a soil type phase, and I'm still working with a full chamber, and that's what's generating this high specific energy. So here you can start and change in the operation mode gradually to an open mode, or let's say to an open mode with screw conveyor, I mean. So with lowering the material, the level of muck in the excavation chamber. And here we can see we manage by adjusting all the pressures go down. This means at the same level. So this means we're operating in more like an open mode, and the specific energy goes down, and effectively we're now working with penetration indexes similar to those in full phase rock. So this is a timely adjustment of the TBM operation mode to the ground conditions. If this TBM had been operating with this full phase, with this high specific energy up to this point, I'm 100% sure in this position there would have been a huge damage on tools and maybe even on the. So after these examples and after pointing out several aspects of how to approach risk management, I would like to present here the concluding remarks. Number one is that construction risks are increasing. It's not like they are decreasing. On the contrary, projects are more challenging. We have larger diameters. We have more difficult ground conditions to handle with. Then, obviously, risk management is key in all the stages of the project, from the contract to the project delivery. And we still have losses and accidents occurring, and we have many cases where you actually see these were avoidable. And so we are actually in a very risky industry where risk minimization requires a multidisciplinary and expert approach. There's many fields involved, including legal, including the engineering, including the geology. And then obviously the ground conditions are the primarily source of risks. But here there's not much at the time. There's not a high, let's say, perspective of improvement in improving the interpretation of the ground conditions yet. So in consequence, we have to sometimes design too conservatively, and then it's imperative during construction to observe and validate the design assumptions. And then I would like to point out, I think construction technology is advancing very much. There's a lot of innovation going, and there is technology available to minimize risks efficiently. But unfortunately, what we see sometimes is that the tools available to minimize the risks are not always used at their full capacity. So with this, I finish a presentation. Thank you very much. So if you'd like to, yeah.
Thanks so much, Mark. It's a fantastic team. Yes, there I am. It thrills me a lot because it's very much the team of my PhD and now from my postdoc. Before the people start making questions, I have some for myself. I really like several of your slides. And you mentioned quite a lot about the ground conditions, right? That the ground conditions are a primary source of risks. And we have the GBR and how important it is to bring all this information in the GBR. And as well, you mentioned the importance or the effect that wear and clogging and the soil condition has in the risks of tunneling, and why we are not bringing actually all this characterization and evaluation of wear or wear estimation of wear, clogging, and as well as the characterization of soil conditioning in the GBR. Wouldn't make sense as well, because we are focusing the GBR perhaps very much in the parameters that, yes, it matters a lot, but also these aspects, the influence of wear and the estimation of clogging, they matter as much as the other ones. Wouldn't make sense to include that in the GBR as well.
Yeah, of course. I guess it would make sense because at the end of the day, it's not only the geotechnical parameters; it's actually the interaction of the geotechnical parameters with the actual construction process. But what you mentioned obviously implies using certain models to estimate the wear, for instance, or the clogging potential, and all these models, they're still in not fully consolidated, as you know, because it's so difficult to estimate these things. So I think it's what then owners do is, of course, this step of interpreting what are the effects on the construction method. That lies on the more on the contractor's experience and know-how on these aspects. Yes. So that's why I think it's the models available, the tools available to do this are not yet, let's say, developed or safe enough for a tender document or a baseline document to use it as a baseline condition, I guess.
I wouldn't totally agree because, as an example, we know that we have clay stones in the case of open TBMs, and clay stones is something that it can have a clogging potential, for example. And it's very simple to just grate this rock and then do other berg limits, but in most of the cases people are not doing. Or, for example, you can achieve lots of conclusions by doing lots of tests that are already available in the market. You know, there's lots of publications, and it's not about the model, but it's simply to check, okay, what's my condition here? Do I have a soil that has potential to clog? Do I have a soil that has a potential to have high wear? So we do have already in the market. I think many times it can be quite simple. I just think that we just need to push more for this test to be done.
No, actually, no. I do agree with you in the field of clogging. There is this potential, and there's all these studies that Marcus Tevis has done, that you have done, and actually you see them reflected nowadays in the US. I was mentioning before the US from their guidelines, and actually you do see now definitions of clogging potential of the ground. They're actually classifying the clogging potential of the ground in many projects nowadays. That's true. In the field of clogging, I think it is possible, but in other aspects like true wear and all these aspects, it's probably more difficult.
Yes. Soil conditioning as well.
Yeah, soil conditioning. Yeah, I mean clogging, and then the soil. Well, obviously, then the soil conditioning is more on the hands again of the contractor, but the baseline conditions are telling you, okay, you have a high clogging potential here, so please present an acceptable conditioning program.
Because this is something we have been discussing a lot when I was in Germany, actually, in the German Geotechnical Society, to actually bring that already in the project stage, to not wait until you have you're excavating your soil or your rock and then you start getting problems and try to solve from there, but actually to try to foresee these problems before.
For sure, but we're having these problems always still in so many projects, and yeah, I guess this could be tackled from the earlier stages, from a baseline condition. Yeah, agree.
I have a question here from Eloy. Eloy is the current treasurer of CBT and our future president. Mm-hmm. He asks, in your country, the public contracts have the same risk sharing as a private contracts?
You mean in Germany or what? Oh, sorry.
I would say so.
Yeah. Well, I'm not aware of that. I'm not aware of that.
Yeah, I'm not sure as well. Well, we have also lots of people saying hello to you. We have, before I go to other questions, I have lots of questions. Werner is saying great presentation. Adriano is saying hello. Fernando Leiser is with the account of his daughter is saying thank you, Mark, for sharing your experience with us again. Giuliani from the young members, Valentin Rob, and Jairo as well. I have some questions. If somebody, please send us questions. Otherwise, I will ask more. I will take the chance. Do you think that tunneling risks are increasing overall, or things are improving with new TBM technology? As when we have more TBM, you think, is there something that you see changing?
I think risks are increasing. And at the same time, I think technology has developed very much. But what I also realize is that the processes are not being updated or being used, and the technology is not always being used at its full capacity to attain the maximum efficiency in the risk minimization. So, as I mentioned before, I do think risks are increasing. Projects are getting more and more challenging, and I'm not talking about only safety risks. I'm talking about financial risks also, and so I believe risks are increasing, while technology is also innovating and developing very well, but the application is sometimes not 100% satisfactory.
Valentin Rob is asking, thanks for the presentation. And does clogging cause incident with dramatic effect on material or people?
Clogging, well, it can have it for sure on material incident, but it can have effects on people very much, because we have a completely high clogging, very high clogging in an EPB excavation chamber. Then there comes to a point where I cannot control the face support pressures properly, I cannot stabilize the face pressures, and actually we've lived these situations where we have collapses then because of clogging. Yeah, the clogging has not allowed us to control the face support properly, and then this has resulted finally in a collapse all the way to the surface.
Yes, I can see this happening a lot in our type of ground, the mixed face, right? Because you have the same time clogging happening, and then right in the position where you stop to do an intervention, your face is not actually stable.
Exactly.
We have Werner is asking, top technology TBM plus, that's very interesting, top technology TBM plus experienced team versus normal TBM plus experienced team. Which one is a higher risk to a project? So you have a super TBM, but with an experienced team, and then you have a okay TBM, but with experienced team.
But the first case is also with experienced team.
No, unexperienced.
Unexperienced. Sorry, I didn't hear properly. No, the first case is more critical. There's no doubt.
Yeah, I agree.
There's no doubt.
Yeah, we need the experienced team. That's essential.
Yes.
Guilherme is also saying, good afternoon, great presentation. Thank you, Mark. I had another question as well prepared. You point out net advance as being impacted 25% by ground conditions and 75% by design operation. How do you relate these baseline ground conditions in assessing delay?
Exactly. I mean, it seems very, very little that the ground impacts only 25%, let's say, of the ground conditions on the net advance rate, or overall in the project, because, well, I think the attainable advance speeds or penetrations of a TBM, there's not such a high range there. You either go at, well, it's very, very hard rock, you'll only attain 5 millimeters per minute. In soft rock soils, you'll be at 40 millimeters per minute or 50. But let's say in soils, we're always in the range 20 to 40. In rock, we're always in the range 5 to 10. And so that is very clear. You don't need very sophisticated models for that. So I think and at the end of the day, the impact of the net advance time in shield tunneling on costs and time is pretty minimal, unless you have very long tunnels. But in normal lengths of tunnels, let's say 4 to 10 kilometers, the net advance time doesn't have that much impact. So a delta, a reduction of your net advance time will have a very low impact in the total schedule or cost of the project, whilst other aspects like the interventions or the tool procurement, construction of tools, etc., that has a very, very high impact. So in that sense, I don't think that ground characterization is at the end of the day so important for the estimation of net advance rates. That's what I'm meaning with that. I think what's very, very relevant for a project is that to have reliable data on aspects like mixed phase conditions, where are they occurring, when I can have situations where I can have higher tool damage, higher tool wear, etc. So that's a little bit what I meant with that.
Still in this area, I also had another point. What about the muck disposal? Because I can see that in the logistics, this is a major aspect, right? Because many times I have seen that projects that they stop because they don't have space to put their muck. Especially now with the environment restrictions, that you need to test your muck. You cannot move the muck anywhere before it gets tested, and the tests sometimes are taking 1 week to be performed. Exactly. Don't you think that the muck disposal will have a major effect, especially now with the environmental restrictions?
Very much, completely. I mean, it's an aspect that's probably been quite disregarded until now, but mainly because probably there weren't as many regulations. Now there's more regulations in this field. And certainly it's a major aspect, and it's driving the costs of many projects. Believe me, there's like the Alpfolland tunnel here in Germany. There's a big claim there with unforeseen, let's say, contaminants, and also in Melbourne, as I mentioned. This is a huge issue involving loads of millions of dollars. Yeah.
Yes. Jairo has a question. Mark, have you seen the application of the Emerald book in the contracts in the past year and a half?
No. No, I haven't. So no, I haven't actually. Not in the projects I've seen, obviously. It's only a very limited amount of projects I've seen, but I haven't, no.
And do you think that this could perhaps help to manage better the risks?
If it's applied correctly, yes, I think so. Yeah.
Yes. Yeah, sure. I think there's still a lot to research on mechanized tunneling. I hope we can improve more and more and slowly solve all these gaps.
Mm-hmm.
I don't see any more questions. I think I asked a lot. Otherwise, they won't let me moderate anymore if I keep asking. I'm joking. Mark, do you have any other remarks regarding the presentation? I will come back to you for the Merry Christmas and Happy New Year part. Before I give some reminds, if you wanted to talk anything more about the presentation or anything.
Oh, well, just maybe a brief note to conclude. I mean, I mentioned it already. It's a risky job. There's a lot of risks. There's many risks which we can handle very easily with nowadays, and it's on a daily basis. We're handling with this risk, like working in stable ground conditions, very difficult things we're doing and doing them very well. But on the other hand, there's still many issues regarding, I think in this case, maybe more aspects of losses but it has a big impact at the end of the day on the cost of the project or even on the price that contractors at the end have to pay, that there needs to be a more clear, fair distribution, I think, of the risks. Risk allocation is crucial, I think, between contractor and owner, and we have to make things fair for the contractors and also for the owners, of course. I think that's a big step. And the second point I think I would like to highlight is that we do see when we are consulting in projects, and many times we are consulting after given events that have occurred, where situations have been avoidable, no? And the risk management plan, maybe on the paper it was fine, but the application, I think I mentioned that several times, the application in practice of these measures is not always as satisfactory as one would expect. So I think there's also things we can improve there in that aspect.
Yes. Before I go to my message here, I have a list of things I need to remind to say. Werner is saying Frohe Weihnachten, stay safe. And then I can go to, so this is the last webinar of the year. Thank you very much for the participation, everyone. Next year we will have more, perhaps with a more reduced frequency. This Friday we have the Tunnelers talk at 5:30 in the afternoon. It's in Portuguese, but we had already some colleagues from Chile. Everybody was speaking Spanish. So if you want to just come and you're most welcome, we can always switch to English. Everybody is very keen to practice their English. Very important. So next year we're going to have the 5th CBT, the Brazilian Tunneling Congress, in the end of the year. So hopefully everybody will be vaccinated by then, and we can finally meet again personally. And so we have already open for abstracts. Please send your abstract. You're most welcome to send abstract in Portuguese, Spanish, or English. We welcome all our international colleagues, companies as well, to actively participate in our Congress. Also, regarding the ground investigation, we have translated the Working Group 2 recommendation for ground investigation from ITA into Portuguese. And next year, I'm quite sure that in the first semester, we're going to have this in Portuguese. I believe I have said all. I would like to wish you all Merry Christmas and Happy New Year from me and from myself and from all CBT colleagues. Hope to see you all again actively. And then I leave you the time, the space for you to say goodbye, Mark. And thank you very much for the second lovely webinar.
Well, thank you very much, Daniela, for organizing it, for hosting it. Thank you, Guillermo, for the technical part. We can't see you, but there you are. And well, I would like to say also Frohe Weihnachten to Werner, Bom Natal to all my Brazilian friends, Fernando, and obviously you, Daniela, also, and Happy New Year. And I'm really looking forward to 2021, not only because the vaccine is coming, but also because we have a lot of exciting talent jobs going on in Brazil. So this is moving. This is nice.
Yes, it's coming. It will get very active here in Brazil. So
exactly,
that's a great time for having a Brazilian tunneling conference by the end of the year.
Correct.
So thanks everyone. Thanks for coming, and I hope all you stay safe and well with your family and enjoy. Bye.
Bye-bye. Thank you.